So what we are going to see is hosting the databases directly on SSDs and running these database benchmarks versus caching hard drives using the DragonFly card, and we're going to compare the performance.
Okay. I'm still a bit confused. That I can get the NV cache and cache some external backend storage.
Mm-hmm.
Or I can get the NV drive and set it up as an NVRAM device and SSD devices.
Mm-hmm.
But I can't get an NV drive and use the NVRAM as a cache to the SSDs?
So far, we have not
Haven't implemented
that option. It is possible, but
Yeah, no, it's just code.
Yeah.
Just seems like, that would let me use MLC SSDs, absorb all the writes in the NVRAM to extend the life. Could give me nice performance at a reasonable cost.
It's possible. Depends again on
Yeah,
how you're using it.
Yeah. And it always depends on the workload, because as soon as you exceed the capacity of the NVRAM cache, all hell breaks loose.
Right.
But that's just the nature of a write cache.
Yeah.
Anytime you're caching writes,
Yeah.
the instant you have one more writes than fits, you're in bad shape.
And problem is, when you do something like that, and most people who would test this kind of configuration, they expect that, NVRAM is going to accelerate everything, even if it's like 100% random over all SSDs, you're going to see that benefit.
That's not how caches work.
But so instead of trying to fight that battle, we are saying, you decide what data you want to put in NVRAM, and you have that control.
Which makes sense for your traditional OEM customers, where they're building a storage system.
Yeah.
But okay, so NV drive is for that set of customers, and NV cache is the end user.
Okay, so what we're doing in here is we have 4 VMs per server. The GUI in the left is where we have the no cache configuration, and on the right is where we have DragonFly configured in write-through mode. So for VMs 2, 3, and 4, we're running each of these VMs in autopilot mode, which is basically MySQL Hamirora traffic running in the background. And then we're going to run, to demonstrate the TPM in real time, we're going to run Hamirora in real time here in counter manager mode, transaction counter mode. So I've already started the autopilot on all the VMs. I just need to start it here on the right. On the left. One more. So there's an initial ramp-up stage, but after the ramp-up stage, it will show an improvement in the TPM numbers that ranges between 5 to 10x in real time. 376. Performance 12. Okay. Okay, so this is running. It's running. This is running. This is a capture of what we are able to, it's a screenshot of the run that we were able to run earlier, just prior. We're on the left where, in the main VM, it's running at 76,000 DPM, and on the right is 657,000. It's like a ratio of 10x in one instance. It's fluctuating.
Oh, I see.
It's done. So this is with cache configuration, and this is no cache configuration. So I'm going to just readjust the screen here. At the end of this run, so the duration of this test is about 30 minutes. And then at the end of each run, there's a 10-minute that's needed to collect the total TPMs. So typically when we perform this type of tests, we either run it in counter manager mode, in transaction counter mode to show the TPMs in real time, or in autopilot mode to collect the data. We're losing connection here. So in the white paper that we are publishing, we're showing 10x improvement by utilizing 4 SanDisk X110 SSDs.
So as you can see, even though the right-hand side is actually hosting the databases directly on SSDs, as opposed to the left-hand side, the database is actually on hard drives, but cached through the DragonFly. You can see the performance on the left-hand side, which is the DragonFly cache, is 5 to 6x higher than the all SSD cache, all SSD database.
And then on a more powerful system, like we have other sets of servers which are equipped with Romley 2600 series processors running at 2.9 gigahertz. We're able to run 8 VMs, similar number of VMs concurrently, and we're able to achieve about 6 million total IOPS on the cache configuration. So in this particular example, 600 times 4 is about 2.4, but with a more powerful system equipped with 64 gig of RAM, 8 VMs each, we're able to achieve 8 million, depends on the configuration, 8 million TPMs.
So what this shows is you can actually run multiple database in virtualized environments and have excellent performance if you're using a DragonFly cache.
So it seems pretty clear that you guys aren't going to be the bottleneck here. Whenever somebody comes to you and says, hey, we have a really great application that we think could benefit from you, do you ship them cards, or do you work with them to kind of, really optimize the platform that they're building? Because it seems like it would be really easy to completely undercut your performance by building a crappy system if I didn't know what I was doing.
I'm not sure that is true. I mean, right out of the box, if you use it in the standard way, right? Well, you need to know whether you want to run it on the server side or the target side and apply the right policies that you want. But out of the box, it's going to be a cache, right? So as long as there is random read-write IOPS, that is the bottleneck in your current system performance, putting the card in there is going to help that situation. So it's not like we have to do any special tuning to get these numbers.
No, I'm sure. I mean, it seems very solid. I am not an expert in this aspect of it, but it does seem very solid. I just didn't know to what degree it was susceptible to other bottlenecks cropping up.
Yeah, I mean, whenever you're dealing with performance, it's always going to be surprises in terms of where bottlenecks come up, right? And you start looking at a performance problem, you're always, peeling the onion, right? It's not always clear it's going to be the storage IOPS that's the bottleneck. But assuming that you've done that and figured out that storage is your problem, this is going to be the solution.